Welcome to School of Chemistry. In today's lesson, we're going to be looking at how to balance a chemical equation. Before we progress, let's look at what a chemical equation itself is. Simply put, a chemical equation is a shorthand way of representing a chemical reaction. For instance, when a husband marries his wife, they'll produce children. So representing this chemically, if we represent the name of the husband with H, and the name of the wife with W, and the name of the children with C, we can write a chemical equation for this. We're going to say H plus W will give C. Because the husband and the wife combine, we call them reactants. And because the children are produced or being formed, we call them the product of the marriage. So this is all what a chemical equation is, a shorthand way representing a chemical reaction. Basically, in chemistry, or in writing chemical equation, we use the symbol of element to stand for the names of the element. So if hydrogen reacts with oxygen to form water, we're going to write hydrogen, which exists as the atomic molecule, H2, and oxygen, the atomic, O2, to form water, H2O. Now, to understand how to balance a chemical equation, let's look at the number of atoms on the reactant side, be the left-hand side, and the product side, be the right-hand side. On the left, we have hydrogen, which we write as H, oxygen, which we write as O. On the right, we also have hydrogen written as H and oxygen O. So on the left, the 2 on the hydrogen stand for 2 atoms of hydrogen, and the 2 on the oxygen stand for 2 atoms of oxygen. On the right, hydrogen has 2, and we'll write it as what? 2 atoms of hydrogen, and oxygen, 1 atom. When you don't see a number associated, it means the atom is what? 1. And if you do an atom check, you see that the number of oxygen on the left do not balance with the number of oxygen on the right. Meanwhile, the number of hydrogen balances with the number of what? Hydrogen on both sides. The law of conservation of matter states that energy can neither be created nor be destroyed, but can be changed from one form to another. Also, in balancing chemical equation, you do not destroy atoms, but you can change them from one form to another. And we'll do that by adding coefficient to what? Each of the atoms in reaction. For example, if sodium reacts with oxygen to form sodium oxide, symbol for sodium is Na, that for oxygen is O2, and then the formula form, the compound form is what? Na2O. Let's check the number of atoms on both sides. On the right, we have 1 atom of sodium and 2 atoms of oxygen. On the right, N2, 2 atoms of sodium, and O, 1 atom of oxygen. The number of sodium is not balanced, and the number of atoms of oxygen are not balanced either. So we start balancing by adding 2 in front of Na2O. When you add 2, what happens? We're trying to balance the atoms on both sides. Now the number of oxygen atom now is 2. That is 2 times 1 atom before. 2 times 1 will give you 2. Now that of the sodium, we have 2 times the 2 atoms of sodium that were there before. So you have 4 atoms of sodium and 2 atoms of oxygen on the right. So on the left, now in balancing that, we are going to say 4 times the 1 atoms of sodium will give you the 4 sodium. 4 atoms, and then we'll come and put 4 as a coefficient, the number of moles sodium, and that is 4 atoms of sodium. Then 1 times the 2 atoms of oxygen before will give us the 2 atoms of oxygen. And in that way, you see that we have 4 atoms of sodium on the left and 4 on the right. 2 atoms of sodium of oxygen and 2 on the right. Let's look at another equation. Ammonia reacting with oxygen to form water and nitrogen gas. So we have NH3, O2 reacting to form H2O plus Na2. Let's do an atom count. If we do an atom count, on the left, we have 1 atom of nitrogen, H3, 3 atoms of hydrogen, O2, 2 atoms of oxygen. On the right, we have N2, 2 atoms of nitrogen, H2, 2 atoms of hydrogen, and O, 1 atom of oxygen. If you look on both sides, none of the atom is balanced, and we'll have to balance this equation. So we'll balance by what? Adding numbers in front. If you put 4 in front of NH3, now what are the new atoms present? We're going to have 4 times 1 atom of nitrogen will give you 4 atoms of nitrogen. 4 times 3 atoms of hydrogen gives you 12 atoms of hydrogen. Now we'll have 4 atoms of nitrogen on the left and 12 atoms of hydrogen on the left. We have to go and balance it on the right. And to balance this, we're going to have 2 times 2 will give you 4 atoms of nitrogen. So we'll put 2 in front of nitrogen, and that gives us the 4 atoms of nitrogen. Now hydrogen is 12 on the left. If you multiply the right by 6, you get the 12 atoms. So 6 moles now in front of water will give us 12 atoms of hydrogen. 6 moles in front of hydrogen of water will give us what? 12 moles of 12 atoms of what? Hydrogen, because 6 times 2 is what? 12. Now oxygen on the right will have 6 times 1 already on the water, and that will give us 6 atoms of oxygen. So we need to balance the oxygen on the right by multiplying 2 by 3, and then we'll get 6 atoms of oxygen. And then we'll have to write 3 in front of the O to make it 6. And in this way, the equation is balanced because we have 4 nitrogen on the left, 4 on the right. 12 hydrogen on the left, 12 on the right. 6 hydrogen on the left, 6 on the right. This is how to balance a chemical equation. Classwork, do this for us and leave the answer in the comment section. Balance the equation. KClO3 decomposes to give us KCl plus O2. Leave the answer in the comment section. If it's your first time on this channel, please do not forget to subscribe, like, share, and comment. Thank you.